Hi everyone, welcome to my video where today we're going to talk about how to graph a radical function and understanding the transformations of a radical function, particularly a square root function. So let's take a very quick look at this. So first of all, we have this formula f of x equals a times the square root of x minus h plus k. We should already be very familiar with a, h, and k as we use them for our absolute value functions and we saw them in our quadratic functions. And the same transformation properties that they had there, they still have here. So if the absolute value of a is some number that's greater than 1, it's going to have a sharper curve. In parabolas, remember it made it like a skinnier graph. If the a value, the absolute value of it, is somewhere between 0 and 1, it's going to be a wider curve. The same way in a parabola, it became a wider or like fatter open graph. And if a is negative, it's going to make the graph reflect vertically. Now, h and k are not referred to necessarily as the vertex, but they are the point where the graph starts. And h still is all about the horizontal shift, and k is still all about the vertical shift. So we already have those key points that we know from previous lessons, and we're going to use those to apply them here today. So when graphing, we have 4 steps. Step 1, make a table of values starting with the point hk. So we're going to look at what our vertex would be, and we're going to use that as our starting point. We're not going to put it in the middle of the table like we did in previous lessons. Instead, it's just going to start our table. We're going to calculate more ordered pairs for the table, and I'm going to show you the best way to really do that effectively. We're going to connect the points with a smooth curve. We don't know what this graph looks like just yet, guys. And we're going to calculate the domain and range, things that we've already been doing before. So let's take a look. Here it says we're going to graph y is equal to the square root of x, so that's going to be our parent function, and then we're going to graph this transformation, y equals the square root of x plus 5. So the first thing I want to do is just graph this parent function. Now think about it. Y is equal to the square root of x. If x is 0, what's the square root of 0? 0. If x is 1, what's the square root of 1? 1. Can we take the square root of 2? No. Square root of 3? No. Square root of 4? Yes, it's 2. Square root of 5? No. 6? No. 7? No. 8? No. 9? Yes. Square root of 9 is 3. So here's what I want you to see. This graph is a curve that looks just like this. This is our parent function, guys. That's our parent function. And if I look at that parent function, I see it's kind of interesting. It's got this starting point and it's a curve. I kind of think about it like a water fountain. Like think about it if you were in school and you turned a water fountain on, the water just kind of shoots up like that. It doesn't go up really high. Well, sometimes it could. This is kind of how I just picture a water fountain going out. Now let's graph this next function. This next function says y is equal to the square root of x plus 5. What we want to do is we want to start with our starting point. Now the starting point is our hk. Now here, I don't see x minus any h value, so that would mean my h value is 0. My k value is always the number at the end, which I see is this plus 5. And that 0, 5, guys, is going to be our starting point for our graph. So the first thing we do is calculate our hk. Then we go ahead and think about things you can actually take the square root of. What would be the next natural number you could take the square root of after 0? It would be 1. The square root of 1 is 1. 1 plus 5 is 6. So 1, 6 would be our next ordered pair. Can I take the square root of 2? No. 3? No. 4? Yes. The square root of 4 is 2. 2 plus 5 is 7. So 4, 7 would be our next point. 5? No. 6? No. 7? No. 8? No. 9? Yes. I could take the square root of 9. It's 3. 3 plus 5 is 8. So here I'm at 3, 4, 5, 6, 7, 8. And that's my curve. So now, if I really needed to describe what's happening here, first of all, my domain. Domain, remember, means all of your x values. And here, it looks like for this graph, we're talking about this one that we're graphing in blue, the domain, the x values start at 0, and then it's everything greater than 0. So I'm going to say the domain values are all x values that are greater than or equal to 0. The range is always about the y values. And the y values of this graph start at 5, and then they're everything above it. So y is greater than or equal to 5. The transformation, what do you notice happened from this parent function to my new function? Each point simply just went up, look at that, 5 units. That's it. It just simply went up 5 units from the parent function. Pretty simple. Let's try the next one. I've got my parent function. I'm going to go ahead and graph it just like we had done before. So my parent function of 0, 0, 1, 1, 4, 2, 9, 3. But now let's graph this new function, y equals the square root of x minus 2 minus 1. So I have to figure out my hk, right? So if it's x minus h and I see x minus 2, then that means my 2 is my h value. My k value is whatever is at the end. So if I see minus 1, then my k value is that negative 1. So 2, negative 1 is going to start my graph. So 2, negative 1. Now think about that. 2 would be the smallest number I could actually plug in here because 2 minus 2 is 0 and the square root of 0 is 0. So I have to think about it. What would be the next number that I could plug in for x to be successful? If I plugged in a 3, 3 minus 2 is 1. Can I take the square root of 1? Yeah, the square root of 1 is 1. And then 1 minus 1 is 0. So 3, 0 is actually my next point. If I plugged in x is 4, 4 minus 2 is 2. Can I take the square root of 2? No. If I plug in a 5, 5 minus 2 is 3. I can't take the square root of 3. What if I plugged in a 6 for x? 6 minus 2 is 4. The square root of 4 is 2. 2 minus 1 is 1. So 6, 1. Now, I bet a lot of you are already seeing what's happening from the parent function to this new graph, but I'm going to just do the last one. I wouldn't be able to plug in a 7 because that'll give me 5. 8 would give me 6. 9 would give me 7. 10 would give me 8. 11. 11 would be good because 11 minus 2 is 9. The square root of 9 is 3. 3 minus 1 is 2. So 11, 2. And I'm kind of off my grid here. Okay, my domain means my x values. My x values are starting at 2, and then they're everything greater than it. So x is greater than or equal to 2. My range is always about my y's. My y values start at negative 1, and then they're everything above it. So greater than or equal to negative 1. And now my transformation. Remember, the vertex, or in this case hk, tells you the transformation. So from this point here, look, it went to the right 2, down 1. Look at this next point. To the right 2, down 1. So that's exactly what's happening. Right 2, down 1. And that's what this vertex is really telling me. To the right 2, and then down 1 unit. Pretty good. Okay, I'm going to go ahead and graph my parent function here rather, just like I did in the other one. So 0, 0, 1, 1, 4, 2, 9, 3. And now let's look at our next function. So I need the hk. If I have y is equal to 2 times the square root of x, then I don't see an h, so my h is 0. My k is the number at the end, 3. So 0, 3. But the only thing different about this equation now is this 2 is my a value. And think about it. For a parabola, it made the graph skinnier. And for a radical function, I said it's going to make it like a sharper curve. So imagine this was like a hill you were skiing down or wanted to roll down a hill. We're going to have a hill that's a little bit of a sharper angle. So 0, 3 is my starter point. The next number I could take the square root of is 1. So now follow along with me. Ready? Square root of 1 is 1. 1 times 2 is 2. 2 plus 3 is 5. So 1, 5 is my next point. Now I think you can already see how much sharper this curve is going to be. Because look, this one's kind of starting flat and this one's already jumping up pretty high. Next value for x that I could actually take the square root of is 4. Square root of 4 is 2. 2 times 2 is 4. 4 plus 3 is 7. So 4, 7. And then last number I could take the square root of is 9. Square root of 9 is 3. 3 times 2 is 6. 6 plus 3 is 9. So 9, 9. And definitely a sharper curve than the parent function. So my domain, my x values are all values that are greater than or equal to 0 because it starts on the x-axis at 0 and is greater. My range is about my y values, starts at 3, everything above it, so y is greater than or equal to 3. Now, two things happen in this transformation. Not only is it a sharper curve, but remember this 3, that also means it went up 3 units up. Okay, excellent. Last one. I'm going to go ahead and graph my parent function like we've done for every single problem so far. That one becomes super easy to graph after a while. My hk from my new function, x minus 1. So my h is 1. And then I've got my k value of 4. So 1, 4 is where I'm going to start. So 1, 4. Now, the difference here is that my a value is negative. And remember, for a negative a value for a parabola, it reflected it vertically. So the same thing's going to happen here. Instead of my curve looking like this, it's going to look like this now. All right, so 1 would be the smallest x value I could plug in because 1 minus 1 is 0. Square root of 0 is 0. The next x value I could plug in is a 2. So ready? 2 minus 1 is 1. The square root of 1 is 1. Make it negative. Negative 1 plus 4 is 3. That was a mouthful. So we plug the x value in, we subtract 1. We take the square root of it. We then make that answer negative because that negative is on the outside. And then we add 4. Next x value that I could plug in, 3, no, 4, no, 5, yes, because 5 minus 1 is 4. Square root of 4 is 2. Make the 2 negative, so negative 2 plus 4 is 2. Last number I could actually plug in here is 10. 10 minus 1 is 9. Square root of 9 is 3. Make it negative. Negative 3 plus 4 is 1. So I have 1, 4, 2, 3, 5, 2, 10, 1. My domain, it's all x values that are greater than or equal to 1. My range is a little different here, guys, because look, it starts at 4, but then it's everything below it. So it's y value of 4 and everything below it. My transformation. So this graph did 3 things. It went to the right 1 unit. It went up 4 units, and then it reflected vertically. So right 1 unit, up 4, and then reflected vertically. Sorry for my sloppy writing. I hope this video was helpful for you. Thank you so much for watching. Bye.